Again, we're going to use these helpful tips in order to help us out. Hopefully I can get to, at some point, further along. You guys ready to go? Not yet? Okay. The one we're most typically using is converting all functions to sine and cosines. That sometimes is going to help us. Sometimes it's going to be using algebra and known identities to simplify. Maybe reducing it down faster before we change it might help us out. Bringing common denominators together, adding them as fractions. Again, factoring, multiplying by conjugate. Start with the more complicated side is always the key. So here we go. Copy down this one here. Okay. This is the thing that I in the red is what I really want you to kind of bold out and give yourself some rooms as we kind of do these. The cool thing about these is it actually tells you the solution. So it says, well, what you're going to try to do is we're going to try to simplify cosine times the quantity secant minus cosine. We want it to show why it's equal to sine squared. Okay, this is an identity we can use if we wanted to. And we want to prove that it works. And so we want to be able to choose one of our sides in order to show that. And it's not going to be as clear as you guys think. Sometimes it might be a little bit harder to kind of see where we're going to kind of go. And let you guys kind of do those. Again, the trigonometric identities on here. We're going to introduce this even odd identities for us. We're going to introduce that probably tomorrow for these and just practice some of these types of problems for us. Yeah. So here we go. Proving an identity by rewriting in terms of sine and cosine. This is something we've already done. And what you guys are used to seeing is this is considered the left-hand side. So LHS of the side of the equation. And on this side, this is the RHS, the right-hand side. And again, you can choose either side to use. Okay, you always want to look for the more complicated parts because it's going to help you simplify out. Okay. Now, using these, what we're going to do here is I'm going to go ahead and start with the left-hand side. It looks like the more complicated side, so that's the side I'm going to show. So LHS is going to be the side I'm going to start out with. And this is going to give me cosine. Again, I'm leaving out the theta. I'll introduce it at the end. I don't like putting it in there because it confuses me sometimes. And I want to work with that in order to get me sine squared. And let's check to see if it's actually going to do it. So what's the first step? What does it tell me to first do? Convert. Just like we regularly would, I would always do that. If it's something you can't see and can't use, we're just going to convert. So I see that secant. So this will give me cosine over, what's secant? 1 over cosine. And then minus cosine. Two approaches from here could work. You can either distribute or you can combine those fractions. It's going to do the same thing. For easier practice so we can do more material, I'm going to go ahead and distribute these out. We're just going to try to simplify like we would just in the dunya. We're just going to try to reduce this as best way we can. So my first term here is going to give me cosine over cosine. We're going to distribute that last one, so it's going to be minus, and then we're going to get, what's cosine times cosine? Cosine squared. Okay, good here. Then let's simplify. Let's simplify this a step further. What happens to cosine and cosine? Cancels and gives me 1. This will be 1. And then we rewrite the remaining term, 1 minus cosine squared, which is one of our trig identities. Our TIs, trig identities, is going to give me sine squared, which is what we want to be able to see, best showing us sine squared theta, which is the right-hand side. Okay, so it tells you the solution. You got to be able to kind of work with them and solve them backwards. Some people think these are easier than the other ones because you know what your direction must give you. Some people like it the other way, where it just gives you a simple solution of secant, cotangent, tangent, right? Another solution. Yes, yes, because this tells me the direction of the proof. We started from the left-hand side, we worked our way to the right. And in some cases, you're going to look from the right-hand side going back the other way. In that next case, that's what we're going to see here. So it just depends. I do want to see that. I do want to see that. You know, and the question is what am I looking for? Like, if you have questions like this on the test, what am I looking for me to solve? And that was one of the good questions I was asking from my other students, and it's seeing these little things of converting, being able to show me the distributive, and using the trig identities in order to give me these values. So on the test, I can't really help you because me helping you might be the difference of you getting the next step in solving and not. That's the difficulty of this, is not helping you, is being able to work your way through it of these solutions. So it's a hard one for me to kind of sit back because it is a harder one, but again, that little help might be the solution to help you get there. So that's where I want to push you guys to get through it. So here we go. Here's our next one. Okay. Again, each of the problems we're doing is a different example type. The first one was changing sine and cosine. This one is combining a fraction. So just like we did for the do now. It's very similar to the do now we just did. Okay. I'll let you guys copy that one down. Okay. So proving an identity by combining fractions. Again, we can look at the left-hand side, the LHS, or we can look at the right-hand side, RHS. And again, it doesn't matter which side you choose to, but one of the things we're going to look at is using the harder formula. And the reason why I say that we're going to use the right-hand side is because if I look at my original problem right here, if I look at this left-hand side, you might think you want to look at that one, but then I have to convert it into this. Is it going to be a lot harder for me to do that than doing it the other way? So you want to look for the harder one because generally it's going to give you more options, more ways of solving it, more operations, and going backwards is a little bit easier than working your way through it. Okay, so what we're going to do for this one is we're going to go ahead and start out with our right-hand side, okay, RHS. And I'm going to go ahead and rewrite it, 1 over 1 minus sine, again 1 minus 1 plus sine. Again, I'm leaving out the theta in there, the x for our angle, just because I don't want to confuse it. We'll add it in always at the end. Just saves me time on writing in space. Combining fractions, right? The biggest thing is like, what step do I use? Well, combine the fraction. How do I combine those fractions? Common denominator. So because this one is very similar to the one on the do now, I'm going to jump without really writing the whole thing out. So this will be 1 minus sine, 1 plus sine. And then if we had to get these two on the same fraction, the left-hand side had to be multiplied by 1 plus sine, and the right side had to be multiplied by 1 minus sine. So I'm just jumping a step here. Okay, I'm jumping instead of writing the whole thing out, because I want to do more problems with you, and I think you guys can do that by yourself. You should be at this point be able to do this. Reducing the best way we can. We want to be able to reduce these down. And in some cases, again, it always gets worse before it gets better. Right? It always gets worse before it gets better. So we're going to kind of look at our values here, and we're going to reduce this down. Can I FOIL this bottom one? Do you remember what the bottom gives us? 1 minus sine squared. Just like the do now. Again, if you didn't like it, you could FOIL it and box method it. Up at the tippy top, we're going to get 1 plus sine. And then distributing our negative, we're going to get minus 1 plus sine. For the top, yes, because we're subtracting the two terms. And then what happens to my value here? What happens to the ones? plus 1 and minus 1, they cancel. Yeah, they cancel. That's a bad way of looking at it. They cancel. Okay. What is sine plus sine? Not sine, not multiplying. 2 sine. 2 sine over 1 minus sine squared. Okay. So again, this is where we want to work. Absolutely. I'm going to keep on working with this. So I want to be able to convert this into, we're going to convert this into cosine squared. This is an identity. Now, this is where it gets tricky. This is where you have to start seeing. What are we trying to get the right-hand side to equal? 2 tangent secant. So I want to try to rewrite it in such a way that I can make a sine and a cosine. So what I'm going to do is I'm going to split these all up. And the way that I'm going to do that is the top is going to be 2 over 1. Whole number is by itself. I'm going to take another set of terms, in this case being a sine and a cosine. I'm splitting it up so I can rewrite it to give me my left-hand side. You'll see in a minute. You'll see in a minute. Okay. I'm not done with my cosine. In this case, I need my last term, which will give me my last for 1 over cosine. Again, all I'm doing is I'm ripping it apart in order to help me to rewrite it in a different form. Okay. We still have cosine squared on the bottom. If I multiply them all out, I still have cosine squared. On the top, 2 times sine times 1 is still 2 sine. So I'm not doing it, I'm just rewriting it. And that's have to do with a lot of these. So looking at this, what's 2 over 1? It's just 2. What is sine over cosine? It's tangent. And then what is 1 over cosine? Is that what I wanted to show? That's what I wanted to show. This is the left-hand side. So copy down this one. And I'm going to reference this as, this one has to be referenced as the conjugate. And the conjugate, I'm going to reference this in blue when I get to it. And what we're going to do is we're going to introduce the conjugate is going to help us introduce to help us solve. Okay. Let's make sure I'm copying this. Introduce to help us solve. Now, again, work with the harder side. And what I see here is I'm going to see that the left-hand side is actually harder than the right-hand side. And I'm going to show you why. This is, if I do give you something like this, I'll tell you, prove the trig identity by using the conjugate. Just because this is what I want to be able to see with this. So let's start this one out. Left-hand side, this is cosine over 1 minus sine. Now, the question that you want to ask yourself, is there anything that I convert? Look at your trig sheet. Look at your trig sheet. Is there anything that is in there that I can convert the top or bottom to help us solve? It's not sine squared, right? But if I can convert it to 1 minus sine, that would help me. But in this case, I don't have anything. You can't split up the fraction. It's not cosine over 1 minus, right? These work a little bit differently. You can't split them up the same way. So we're going to introduce what's called a conjugate. Okay. Does anyone remember what a conjugate is? Okay. It's a term that's going to help you find and simplify out the bottom. It's like reducing a radical, multiplying by the top and bottom by the same radical. What we're going to do is our conjugate for this one will be the opposite of the bottom. And we're going to multiply the top and bottom by this conjugate. It's the opposite. 1 minus sign becomes 1 plus sign. This deals with a lot of complex numbers. You talked about complex conjugates. Very similar to this. Maybe you remember that. Some of you guys don't. But the conjugate for our example here is going to be this 1 plus sign, 1 minus sign. And we're not really doing anything wrong here, because what I can just do is cancel those two terms out. It's just 1. It gives me my original problem. But as long as you're multiplying by 1, any term by 1, it doesn't really change the problem. So let's look at doing this. If we were to put this all underneath one fraction, this would give me 1 minus sign times 1 plus sign. And on the tippy top, we would get cosine times 1 plus sign. And again, some of you guys are able to make that jump and do the multiplication already, which I'm okay with. Let's simplify. If I distribute out my top, what happens to it? Cosine plus cosine sine. Over. And then what's going to happen on the bottom? 1 minus sine squared. So what we're essentially doing here is we're forcing the bottom to give me a identity that we can use. Exactly. So we're introducing a value to help us solve for a value. It's kind of a weird way of doing it. Again, always gets hard before it gets easier. I have to because I know, get used to it. Keep that in my head. There you go. Plus cosine sine. Okay. And then 1 minus sine squared, what is that going to give me? Cosine squared. It's a trig identity that we can use, that we've also seen before, which is the same thing that's going to help us with this identifier. And again, it always gets hard before it gets easier. Okay, let's look at this. So now, do we improve anything? What I'm going to argue is, I'm hoping I did, because now what can I do is I can split it up. So I'm going to split up my first two terms here. So it's going to be cosine over cosine squared. We'll see. Because I want it to try to be this right-hand side, so I want to be able to split them up again. And I'm going to split this right-hand side and doing cosine theta. Yeah. We haven't done theta yet. Yeah. The u here is our theta. Okay. And let's simplify this out. Can I take a step further and simplify this? What is cosine? How many cosines are left for my blue ratio? 1 over cosine. And then what happens to one of the cosines on top? We're left with just sine over cosine. Is this what I want to see? That's tangent. So 1 over cosine is what? Secant. Sine over cosine? Is that what I wanted to show? It's cool math. It's cool. Just this is some awesome math. Okay, and this is what the right-hand side, right? RHS. Yeah, we're still gonna practice this tomorrow, and on Wednesday you're gonna do a new lesson, and then on Thursday it'll just be review. Again, Friday's quiz is all multiple choice. Fridays is all multiple choice. Okay. Cool with that? So we're introducing a conjugate in order to help us out. Let's keep on doing this. In actuality, let's hold off here. I want to stop here. In this case, we can work on both sides of the identity. So we're going to talk about this one tomorrow. Proving a trig substitution. So we'll do this one. Substitute sine in for an expression and simplify. And then this is our homework. Okay. Here's what I want to give you guys for your assignment for 3 problems. I'm gonna give you them just to kind of